Imagine a time when the act of distributing or running a software program felt like a gamble. In the early decades of computing, every application had its fate chained to the specific machine for which it was written. Developers painstakingly crafted their code to work with the quirks of a particular system, adjusting for the tiniest differences in processors, memory layouts, and arcane operating system behaviors. Attempting to run your beloved chess game or finance tool on a friend's computer? Prepare for cryptic errors, strange crashes, or outright failure. On the grander stage, these limitations created silos. Windows programs rarely worked elsewhere. Mac software was its own world. Unix tools ran only on certain flavors of Unix. This chaos stifled collaboration and narrowed the scope of software's reach. The promise of a global software marketplace was held hostage by incompatibility. The question facing engineers was profound. Could there be a new layer, a sort of universal operating layer above the operating system itself, that would shelter programs from the unpredictable wilds of underlying hardware? Enter the runtime environment. The idea was as simple as it was revolutionary. Give every application a standardized, predictable little world to live in. Like a translator in the United Nations, a runtime environment, such as the Java Virtual Machine, JVM, or .NET Common Language Runtime, CLR, could interpret and run code written for it, handling all the messy translation between a program's needs and a machine's realities. Write your program in a language like Java or C#, and it would run anywhere that supported the appropriate runtime environment, regardless of the underlying OS or hardware. Suddenly, the dream of write once, run anywhere moved from science fiction to software engineering reality. How did it work? Instead of compiling software directly to machine code for a specific environment, developers compiled to an intermediate format, bytecode in the case of Java. This code, designed to be understood by the runtime and not by any individual CPU, was then executed by the runtime environment, which translated its instructions into the native instructions for the current computer, on the fly. As the program ran, the runtime also handled memory safety, garbage collection, and cross-platform quirks invisibly, relieving developers of thousands of potential pitfalls. When Sun Microsystems launched the Java runtime environment in the mid-1990s, it was greeted with skepticism and intrigue. The promise was grand, but could it be delivered? As Java applets spread across the web, and enterprise developers began to rely on the reliability and security of the JVM, the idea took hold. Microsoft's .NET followed, embracing a similar vision. A managed code environment with powerful safety features and